right, hi, good day everyone. Today we're starting with solving systems of equations. Now, this may sound familiar, it may not sound familiar, but either way, we're going to get through this together. So you have some notes there inside of ClassKick, and I just wanted to review those, and then I'll go back in and add a copy of mine to the Google Classroom. So let's go ahead and get started. So it says systems of equations using B for the cost of a burger, F for the cost of fries, N for the cost of nachos, and S for the cost of a soda. Write equations for each statement below. This would be a good time to pause if you want to try this for yourself. Otherwise, I'm going to just go ahead and get started. I know that here I'm given 2 sodas and 3 burgers. They cost $18. So if S is for sodas, and I got 2 of them, I know that this should be 2S, and I'm buying 3 burgers, so that's plus, and I'm going to use 3B, and all together that's going to equal $18. So I just did the first one with you. Maybe you want to pause it and try this one on your own. Here I go. 5 sodas and 6 burgers cost $39. Okay, so I'm going to pause it and then you try the next 2 and unpause it when you're ready. So pause. Let's see if we were on the same page. Here's what you should have come up with. 2 burgers, 2 fries, 2 sodas, $18. 2 nachos, 3 burgers, 2 fries, and 4 sodas, $38. So that, just making sure we're on the same page. Okay, so by definition, when used together, these form a system of equations. So on that line, it would be a system of equations, which is a set of 2 or more equations with 2 or more unknowns or variables. Okay, by definition, the solution, now this is something that you may be more familiar with, and that's okay. If not, we will get through this together. All right, the solution to a system lists the values that can be used for each variable to make the equations in the system true. Okay, this is what we would do if I use this first example here. If I found a solution using any of these, either I would use probably the first 2 because that is my shorter equations, but I would solve this, and then that way I could figure out what does 1 soda cost or what does 3 burgers cost. Okay, think about this like the puzzles that you see floating around on the internet. Okay, so let me focus and stay on our journey here. These notes are in your ClassKick. Pause me if you need to, rewind if you need to, or anything like that. Okay, so here's 2 samples for us. Now, this first system of equations, this is a 3x3 system of equations because it uses 3 variables, and you have x, y, z as our variables, and it has 3 equations. So this is a 3x3, and I know that looks like a time sign, but we can read that as 3x3 system of equations because it uses 3 variables and has 3 equations. Now, what we're doing right now is just some background information to help us go forward. Okay, so then we have here an example, and it says, which of the following would be the solution to the system of equations? Now, if I wanted to figure out what is the solution to this system of equations, then what I would have to do is substitute in each variable here into each equation there. Okay, so I would substitute in here each variable here for each x and each y and each z in 5.5. And what should happen? Same here. Plug in 5 for x, -3 for y, and z for 1, and then see if that equation, when I plug it in, gives me -3, 4, and 4. So what I want to ask you to do right here is pause it. Pause it and plug it in, okay? But if you need to see it, that's okay. What I'm going to do is do one. All right, here we go. Okay, folks, so what you see here, I just went ahead, I'm going to try C. It says x equals 5, y equals -3, and z equals 1. So I took the first equation that was given, and I plugged in 5 for x, -3 for y, and z is 1. And I want to check to see if that is equal to a -3. Okay, that's the first thing that I want to do. So here we go. All I did here, I substituted in my values. And now what I'm going to do is multiply. According to the order of operations, we have to multiply first. So here, I'm going to get 10. I'll have a plus, and then on the inside here, I have 3 times -3. So this is going to be a -9. And then here, I have -4 times 1, or -4 times 1, so that's a -4, and that is equal to a -3. Okay, so then what I need to do is add. Now, the order of operations is add and subtract, but in this case, what I'm going to do is I'm going to add 10 plus a -9, and that's going to be 1, minus 4, still setting that equal to a -3. And so in this case, I have 1 minus 4, which is a -3, and -3 equals -3. And so just in this case, C works. So I don't want you to stop right there. You have to go to the next 2 equations. So if you would, pause it and then you give it a try. Just in case if you need to see, here I substituted in my values into both equations. And now I'm going to solve. Okay, I know that went by quick, but I just wanted to show you on the second equation, which was x minus z equals 4, it worked. I got 4 equals 4. And then on the third equation, I had -x minus 2y plus 3z equals 4. And once again, it worked. 4 equals 4. So for that reason, C is our answer. Okay? So that's just a little bit of practice. This is how you can check if your solution is correct. Okay, let's go back to our notes. Okay, everyone. So this next sample here, 2, this is an example of a 2x2 system of equations because it uses 2 variables and it has 2 equations. So I'm going to write that down here. And like I said, my intention is to put this inside of Google Classroom so that you'll have it as a point of reference. All right. Now this may seem like something that you have done. It is true that this topic is covered in Algebra 1, but we figure, hey, it's been a while. Let's go ahead and review them. So a 2x2 system, 2 variables, 2 equations. And then we have which order pair shows the solution to the system. So I'm going to grab my paper and then I'm going to work through example 2. Okay, folks, so what I did here, this was sample number 2. So I used my system of equations and I'm going to try B, which has 8 and 1. So for every x, I'm going to plug in 8. And for every y, I'm going to substitute in a 1. So here we go. I've substituted everything in, and so now I'm going to simplify. The first thing that I'm going to have to do is multiply. Following my order of operations, so this will be 16 minus, and 7 times 1 is 7, equals 9. Well, it is true. 16 minus 7 is 9. And 9 equals 9, so we know that 8, 1 works here in this case. I want you to pause it and then you try the next one. Okay, so here we go. We have 1 equals a half times 8 minus 3. I made a little boo-boo right here, so Oops. All right. So anyway, half of 8 is 4. 4 minus 3 is 1. And so this checks out again. So B is going to be our solution. Now, what happens if we have a point that is not our solution? Well, these won't equal. All right. They won't equal at all. Now, there are, excuse me. So this is our notes again. It says below, circle the solution, the correct solution to each question. How can you determine the solution? So what we did early on was we substituted everything in. So I want you to take this time right now and pause and try to make sure that you have the right solution. Okay, guys, give it a chance.